Lesson 10.3, probability with permutations and combinations. Now this looks familiar. I think I've done at least one of these with you guys earlier in the year. Right, so I'm going to do a couple of examples up front that involve a standard deck of 52 cards, and then we'll go into all the book examples. Right? So permutations, you're looking for what's the either the probability of some event happening where the specific order matters, or how many different ways are there to for a specific order event to happen, right? When you get to combinations, it's a similar idea, except maybe the order doesn't matter. So for example, what if I want to draw 4 cards out of the standard card deck of 52, right? So I have a standard deck here, 52 cards. Let's say, so give us a little shuffle, right? Right. Let's say I'm going to draw the top 4 cards, okay? Now, if I'm looking for a specific order of drawings, like what's the chance that I draw specifically the ace of spades, followed by ace of diamonds, followed by ace of clubs, followed by ace of hearts, right? Like, what's the chance of that happening? Now, later on, when we get to combinations, when the order doesn't matter, the question might change to something like, what's the chance that the top 4 cards are just the 4 aces? But they don't have to be in this order, which is, well, going to be a lot more likely, right? Okay, so how are we going to think about this? Okay, well, let's see. Let's say here, and I'll get into this math in a minute. I want you guys kind of where this comes from, the way to think about it. Okay, well, what's the chance that the top card is specifically the ace of spades? The ace of spades. I'd say, well, that would be a 1 out of 52 chance, right? So let's find out. Flip it. Oh, hey, it did turn out to be ace of spades. Okay, that was going to happen 1 out of 52 times. Okay, right. But what about the rest of this, right? So I flip the next card. Well, now I only have 51 cards remaining, right? This one's already locked in place. So the chance of the next card will be the ace of diamonds. Well, there's 51 cards remaining, and only one of those is ace of diamonds. Oh, hey, look at that. Ace of diamonds. Let's go that. Now going on, you can probably see where this pattern is going to be going. Now I have 50 cards remaining, and only one of those is specifically the ace of clubs. So 1 out of 50 that would be. Oh, and it is. And finally, I have 49 cards remaining, and only one of them is the target card. So 1 out of 49. Okay, and that, yep, there we go. And so what's the chance that that happened if it was really random, if I didn't break the whole thing, right? But what's the chance that happened? Well, I've got the answer right here. All I need to do is multiply this out. Okay, so let's see, 52 by 51 by 50 by 49, right? That's all in the denominator. So this is a 1 out of 6 million chance. 6,497,400. Okay. 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 So that's the chance that happens. Okay. Now, permutation starts by saying, well, how many different uh, permutations of 4 cards could you draw, right? Like, what if I change these to 4 other cards, like the 3 of spades, or it was and so on all the way down, right? Right. So, come up with this expression, right? So here's the way you can put this in the calculator. I'll show you guys that in a minute too. And so 52, P stands for permutations, and 4, right? So there's a deck of 52 cards in this case, and we're going to draw 4, okay? And you can do 52 factorial over 52 minus 4 factorial, which is 52 factorial over 48 factorial. That factorial is you're going to multiply all the whole numbers all the way down to 1. So 52 times 51 times 50, 49, 48, and it keeps going 47, 46, so on, right? But 48 factorial is 48, 47, 46, 45, all multiplied, right? And you see right here, these are going to cancel, okay? So it leaves you with this. So there are, hey, does this number look familiar? That looks kind of like this, doesn't it? Right? There are over 6 million different ways to draw 4 cards, and then you run out of possibilities. And then you can say, well, what if I draw these 4 cards? And it's something that you covered already, right? Well, the chance of drawing one specific outcome, and I have one specific outcome, would just be 1 out of that number. Hey, and that's what we were talking about right here. So I want you guys to see what that connection is. Okay? Again, I think what more deeply on that too. Okay? Now, what about combinations where I say, well, the order doesn't really matter so much. Right? So go so what if I want to target the 4 aces again, but they don't have to be in any order. Maybe I could draw the hearts first, followed by, whatever order. Right. Well, in that case, when I draw the first card, there's really 4 potential cards it could be. So it's like 4 out of 52. Okay. And then once I draw that card, and it could be any of these 4 could qualify. Okay. Then I have 51 cards remaining, and there are 3 qualifying cards. And then assuming that I pick one of the aces, there are 50 cards remaining and 2 qualifying cards. And then finally, 1 out of 49. Okay, as I said before. Okay. So everything above this line is permutations. Everything below this is combinations. Permutation, combinations. Okay. All right, so let's check this out. This would be, well, I think this would have the same denominator, wouldn't it? All right, 6,497,400. We ran that already. Okay. But now the numerator is 4 times 3 is 12 times 2 is 24. Right. So there are 24 different ways, assuming that I don't care about the order. Okay. Now, what would that reduce to? So what is 24 out of 6? All right. You know what I'm gonna do? I'm gonna actually take the reciprocal. So that'll be that, right? So 6,497,400 over 24, right? And then go back and make reciprocal again. It'd be 1 out of 270,725, right? So again, if I don't care about the order specifically, I just want the four aces, right? There's a 1 in 270,000 chance that the first four cards I draw will be the four aces, right? Where I don't care about the order, which is a lot more likely, right? Right? Once you don't care about the order, it's a lot more likely to happen, right? Well, the expression for this looks fairly similar, right? You do n factorial, and in this case stands for the 52 cards in the deck, over n minus r factorial, just like before. But now r factorial, hey, that's kind of takes the place of this right here. It's 4 times 3 times 2, where to display that I don't really care about the order of the cards. Okay? Again, how this is specifically set up is it's to say like how many different combinations of four cards could I possibly draw, right? And then you multiply it out. A lot of the factorial cancels. This 48 factorial, 48 factorial cancels. Okay, so there are 270,000 some possible combinations of any four cards I could draw. So the chance of drawing specifically four aces, which is one of those possibilities, 1 out of 270,000. Yeah, there you go. Chance. There you go. All right, so and finally, I do want to show you guys the shortcut way to put this in on the calculator. Again, we've done this, I know, a few months ago, I forget exactly, but let me show you guys permutations. So if I type 52, as in 52 cards in a deck, okay, I'm looking for four specific cards in a specific order. Go to this button that says PRB. So keep NPR for permutations, and then type 4. And your calculator will tell you how many different ways you can draw four cards in a specific order, and it should be this number right here. Let's see if it is. Yeah, it is that number. So the calculator will basically do this for you. There you go. Okay. And then if you don't care about the order, let's do combinations. I can type 52 for 52 cards in a deck, hit PRB. Now I'm going to scroll over to NCR for combinations, C for combinations, and then type 4 for 4 cards. And it should tell me this number right here. Let's see if it does. Yep, sure does. There are 270,000 ways to draw any four cards as the first four cards. Okay. Go back to PRD one more time. There is one more option. It's that exclamation point, which is factorial. That's what you're seeing right here, factorial, which means you multiply that number by all the whole numbers all the way down to 1. So 52 factorial is 52, 51, 50, and so on all the way down. Right, talk about that. All right, so your calculator will handle all of that for you if you want. All right, so there's a broad overview with standard decks of cards. But so what's some examples from the book that maybe don't involve cards necessarily? Okay, right. What are some other story examples? Right, so your book tells you what a permutation is and leads you to this formula, which I went over with you guys. But if you want to, of course, read the book and see their perspective, you can do that too. Right? Now they don't talk about combinations for a while. They just do some example permutations. So let's do that. Okay. We've got performing arts. We got Taisha and Liam sign up for an open mic night with 32 available slots that are filled at random. What is the probability that Taisha will perform first and Liam will perform second? So example 1. Okay, what's the chance? What's the probability? Okay. So if we're looking for specific orders for each of these individuals, and there's 32 slots, I'd say the chance that Taisha is first is 1 out of 32. And supposing she secures that position, to say, okay, we can move on and say, how about Liam being second specifically? Given this, right? Well, now there are 31 available slots and it'd be a 1 in 31. Right? So let's multiply this out. This would be 32 times 31. Right? I'm looking at 1 out of 992. Okay? Now, if you want to express that as a percentage, you can divide it like this. Right, that'd be as a decimal 0.001. Okay, and then 0 something. So round to there, right? I'll say approximately, it's pretty close, right? Or 0.1%. I mean, it's pretty close to 1 in 1,000, isn't it? About 1 in 1,000. Okay, so hopefully that makes sense that way. Now, how does this connect back to this math we did before? There's a different way you could write this. You could say, well, how many different permutations could you have, right? Which should be 992, and then just say one out of that is we're looking for a specific outcome. So let's do this NPR right here, okay? So NPR, right, would be in this case, there are 32 positions, and we're going to do permutations, and we're looking for these two individuals, and we're looking for a specific outcome. So that's going to be 32 factorial, 32 factorial over, and then 32 minus 2, 32 minus 2, and then that factorial. Okay. Now to expand that out, that's 32 times 31 times 30 times 29 all the way down. So I'll just end the factorial right there because you can keep going 29, 28, 27, so on. But 32 minus 2 itself is 30, and that's being factorial. Okay. And you see why I stopped right here because you know, so quickly cancel that. Okay. So it's whatever 32 times 31 is, which actually did up here, which is 992. Okay. And then, so there are 992 permutations of this outcome, right? So that then again, the probability of being specifically these two in a specific order is one out of that, which is what we did before. Okay. That's it there. All right. Next one. Example 2. For a project, Rami selects 12 family photographs that will randomly play in a slideshow. The slideshow will not repeat photos until all 12 photos have been shown. The photos are of Rami's entire family with 2 photos of the brother, 3 photos just of him, 4 photos of his sister. What's the probability that the first 4 pictures in the slideshow will be of Rami's sister? And there are 4 photos, right? And now, I think it's kind of strange how they take you through this because they go through permutations and they expand it. But really, you can think of this as a combinations question, and I'll show you guys that too. So first they say, well, if you do 12 permutations of 4, so you look for a specific order, right? You do 12 factorial over 12 minus 4, which is 8, and then factorial. So 12 factorial over 8 factorial. Okay. Okay, and then that comes out to 11,880. Okay, so there's 11,880 possibilities of any 4 photographs in a specific order. Okay, right, then they say, well, the photos just of a sister would be there are 4 of those, and since we're not interested in order, then those 4 are represented by 4 factorial, which is 4 times 3 times 2 times 1. So we need to divide this by this, which is 24, right? To get like effectively the combinations, even though the word combinations doesn't show up. Okay. Now, if you do that, if you do 11,880 divided by 24, 11,880 over 24, okay, you do get there are 495 different ways for the first 4 photographs to be of a sister in this case. Okay. So the chance of that happening, so the chance or the probability would be 1 out of 495 that would happen. Okay. Now, I would have taken this a different way. I would have just gone straight to combinations. I would say, well, this is really 12C for C for combinations, okay? Which is like, show you guys my combinations right here, right? Okay, so again, the order doesn't matter. Right, so this would be, there are 12 photographs, so it'd be 12 factorial, and then 12 minus 4 factorial, and then 4 factorial. But this should be the exact same thing. It should give me 495, and then the chance of this happening would be 1 out of that. Okay, something like that. Okay, so here, I'll spell it out. So it's 12 times 11 times 10 times 9 times 8, and so on all the way down. So factorial. And then 12 minus 4 is 8, and that's factorial. So this 8765 and this 8765 and so on will cancel out. Okay. And I have 4, 3, 2, 1. Okay. So this and this cancel out. Okay. And this we get 12 times 11 times 10 times 9 is 11,880. And then divide by 4, 3, 2, 1, which we did right here. Yep, it's the exact same thing. There are 495 ways to happen. Therefore, the chance or the probability of that happening would be 1 out of 495. That the first 4 photographs would all be of his sister. So there you go. Okay. Yeah. So really, I think that's better couched as a combinations question. Okay. But maybe they're trying to lead you into combinations. Right, so let's do example 3 here. Maybe another permutations with repetition. one game show has contestants arrange five number tiles to build their guess at the price of a prize. Mishka is given five tiles with the numbers 2, 2, 5, 5, and 8. She arranges the tiles randomly. What's the probability that she arranges them in the correct price of 25852? Right, so she's given these five digits. Can she arrange them specifically in this order? Right? Well, here we're gonna multiply different probabilities together. Right? Like I think the first digit is she gonna get the first digit right? Well, there are five digits to choose from, and there are two that would be correct, right? There are two twos, and the first digit has to be a two. So I would say five choose two, okay? That she gets the first digit correct. Okay. Multiplied by then the second digit. Well, now there are only um, hey, scratch that. I think maybe you guys done the wrong path here. Okay, let's try this again. Right, so there are five, these five numbers here. Right, so 2, 5, 8, 5, 2. Right. So she's got to get them in that order. Right. Well, the chance that she gets the first one in the first place, so this is the way I would think of it, right, is that there are two twos, so it could be either of those. So it's 2 out of 5, right? So there are five numbers to choose from, two of them would qualify, okay? Right, so she gets that one locked in place. The next one, well, there are two fives out of four available numbers, and she's got to get one of those two fives there. Okay? The 8, well, now there are three remaining numbers, and so it's 1 out of 3, okay? And then there's a 2 and a 5 left, so the chance that this 5 is chosen next is a 1 and 2. And if she gets all those locked in place, the chance she gets the last one locked in place, well, there would only be one number remaining. So it should be this. Let's see. So that's a 4 out of 5 by 4 by 3 by 2 by 1. 4 out of 120, okay, which reduces to a 1 in 30 chance. So there's a 1 in 30 chance that she gets these numbers in the correct order. Okay. Now, your book writes this a little different way, and you can probably guess the way they're going to write it based on the way with these fractions. Look here, in the denominator, we have 5, 4, 3, 2, 1. That looks a lot like 5 factorial, doesn't it? That's something about like 5 factorial here. And in the numerator, I have 2 and 2. So I'll say 2 times 2. And if you like, you can think about these being also factorial. Like what if they were like 3 2s or something, right? So these could be like that. So that's the same thing. It's the same thing. Okay. And that's how your book writes it. Now, if they write it as the reciprocal form for like how many different ways could she arrange these five numbers? So they did 5 factorial over 2 factorial, 2 factorial. So they say, well, there are 30 different ways to arrange the numbers. So the chance she gets it in the one of the correct ways would be 1 out of 30. Okay. Okay. So again, yeah, the chance of a particular outcome, you can just take a reciprocal usually. All right. It's a bit more exciting here. We got example 4, probability with combinations. Okay. So they give you this pentagon shape here. Example 4. Okay. I'm going to draw it bigger so it looks better on the camera. All right, get this pentagon. Okay. Got all these dots on it. Dot, 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 dot. Okay. All right, so they're labeled A, B, C, D, E, F, G, H, J, and K. All right. Stay by, yeah. Right. Says if 3 points are randomly chosen from this pentagon, 3 points. There's 1, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so 10 points. What is the probability that they all lie on the same line segment? Same line segment. Okay. Which could be like these three here, that would be valid. Like J, K, and A. That would be valid. These three, these three, these three, or these three. It looks like 5 possibilities, doesn't it? 5 possibilities. So your book says this is going to be a multi-step puzzle. So first you want to figure out, well, what are all the combinations of points that you could choose at all, right? Just like any combination point. And they do have combinations because the order doesn't matter. Like these 3 points here, J, K, and A, as long as you want them to lie in the same line segment, it doesn't matter if you take the K first and the A and then the J. It doesn't matter the order, right? That's why we're doing combinations, not permutations. So I see there are 10 points. I'm going to choose 3. Okay, so 10 choose 3, which you guys remember is 10 factorial over 10 minus 3 factorial, 3 factorial. Okay? So this will tell us how many different ways we can choose 3 points at all. Okay? Now it's not going to be the final answer yet, but one thing at a time. So let's go, here, this is 10 times 9 times 8 times 7 factorial. 10 minus 3 is 7, and that's factorial. And then 3 factorial is 3 times 2 times 1. Okay, so it's maybe a better way to look at it. Okay, so 10 by 9 by 8 over, whoops, 10 by 9 by 8. And then 3 times 2 times 1 is 6, so I'll just do that. So there are 120 different ways to choose any 3 points. Okay? And I can confirm that too by doing 10 NCR 3. Yeah, and it's the same number right there, right? Same thing. Okay, but that doesn't quite answer the question yet. Okay, if we want the 3 points to specifically lie on a line segment, remember before we counted there are 1, 2, 3, 4, 5 different ways for that to happen. Okay, so chance or the probability that the 3 chosen points lie on one segment is, well, there are 5 different ways for that to happen out of 120 different ways to choose all these different points. So it'd be 5 out of 120. Now if I do 120 over 5, I can get reciprocal, right, which would be 24. So this reduces to 1 out of 24. Yeah. Okay, so if you choose any 3 random points on this pentagon, the order doesn't matter, any order, right? What's the chance that they happen to all lie on the same line segment? That's going to happen 1 out of 24 times. There you go. All right. Pretty good, pretty good. Right, let's jump into the book puzzles. I got a few highlighted here. Right, I picked 2 that involve combinations and 2 that involve permutations, so a little diversity here. All right, number 1, cheerleading. The cheerleading squad is made up of 12 girls. A captain and a co-captain are selected at random. What's the probability that Chantel and Clover are chosen as leaders? Okay? Now, notice that it doesn't matter who the captain and who the co-captain are. We just want these 2 to be, take those 2 positions, which tells me this is going to be combinations. So I'm thinking this is 12, choose 2, right? Which is going to be, okay, well, that would tell us, right? Actually, technically what this tells us is how many different combinations of 2 leaders could you choose? And then to say what's the probability of these 2 specifically, we'll just do 1 divided by that. All right, so 1 thing at a time here. So this is going to be 12 factorial over 12 minus 2 factorial, and then 2 factorial. Okay. And if we did care about the order, like, oh, Chantel must be the captain and Clover must be the co-captain, then this would turn into permutations, and then I would bump this 2 factorial here, and it would look more like that, right? But since we don't care who's captain and co-captain, we just want them to be the 2 positions. It's got to be combinations, right? All right, so spell this out differently. 12 factorial is 12 times 11 times 10 times 9, 8, 7, so on. So I'll just cut that out there. 10 factorial is 10, 9, 8, 7, so on. 12 minus 2 is 10, and that's factorial. And then 2 factorial is 2 times 1. So those cancel. Okay. I know 12 over 2 is 6 times 11 is 66. Okay. So there are 66 different ways to choose any 2 of these candidates as collectively captain and co-captain, right? Again, not caring who's captain, who's co-captain. There's 66 different ways, right? So the chance that probability that it's these 2 specifically is 1 out of 66. Okay, so that's number 1. Yeah, okay, so I'm looking at the teacher's guide off camera off to the side. Yeah, they're saying that's the answer. It's 1 out of 66. Okay, number 2, books. You have a textbook for each of the following subjects: Spanish, English, chemistry, geometry, history, psychology. Okay, so number 2. Yeah, I'll call S Spanish, E English, C chemistry, G geometry, H is history, and P is psychology. Okay, okay, so 6 different books. If you choose 4 of these books at random to arrange on a shelf, what is the probability that the geometry book will be first from the left and the chemistry book will be second from the left? Okay. Now, I think choosing 4 of these is a red herring variable because it doesn't matter if you choose, as long as you choose at least 2, somebody's got to be on the left, so guys got to be second from the left. Right? The fact that there are 6 books, I think, is what is relevant. So I think I'm going to call this permutation specifically because they're looking for a specific order. We're looking for leftmost and second leftmost. So I would treat this as there are 6 books to choose from. We're doing permutations because we care about the order. Who's to the left, who's to the second from left, and we need to choose 2 books. So this is going to be 6 factorial over 6 minus 2 factorial, right? Remember, what this tells us is how many different ways can you have a left and a second to left out of these 6 books. And then to go one more step and say what's the probability of these two specifically, the geometry followed by the chemistry, we'll just do 1 out of that. Okay, so this is 6 times 5 times 4 times so on all the way down 3, 2, 1. Okay, and 6 minus 2 is 4. And then that's factorial, so 3, 2, 1. Okay, so factorial. Okay, so it looks like there are 30 different ways, 30 different ways. Okay. Therefore, the probability that it's, what do they say, geometry followed by chemistry. Okay. Again, I care about the order, that's why I did permutations, not combinations. This would be just be 1 out of 30. Okay. And again, I'm looking at the teacher's textbook off camera, and they're saying that's the answer. It's 1 out of 30. Okay. Okay, number 3, raffle. Ooh. Alfonso and Cordell each bought 1 raffle ticket at the state fair. If 50 tickets were randomly sold, what is the probability that Alfonso got ticket 14 and Cordell got ticket 23? Okay, well, let's see. That's a specific ticket and that's a specific ticket. So I'm thinking this is going to be there are 50 tickets. I'm going to do key for permutations and 2 because we care about specific tickets going to each of these individuals. It's not like oh, just one of them got number 14 and the other got number 23. That would be a combinations question, but each ticket has to go to a specific person. Yeah. Right, so that's going to be there are 50 factorial over 50 minus 2 factorial. Okay, which is like 50 times 49 times 48 times 47, so on. So I'll just do factorial and cut right there. Then 50 minus 2 is 48, and that's factorial. So those cancel. Okay. So it's really just 50 times 49. Now, what is 50 times 49? Okay, that should be, okay. So 2,450 ways. Okay. Now, what this number represents is there are 2,450 different ways for these 2 specific tickets to be allocated. Okay. So the chance that Alfonso specifically gets this one and Cordell specifically gets this one, so the probability or the chance is 1 out of 2,450. Okay. Yeah, and the teacher's guide off to the side says that's the answer, so good there. Okay. And so that was also permutations because we care about the order. Okay. Oh, and here, I should show you guys one more thing too, right? Because you can do it this way. You do 50, and then pair B, do NPR, and then 2, and it'll tell you again the number of permutations, possible permutations. Okay. Let's do one more here. Number 5, phone numbers. I just marked as C for combinations. What's the probability that there's a little twist to this one now. Right. A 7-digit phone number generated using the digits 2, 3, 2, 5, 2, 7, and 3 is the number 222, 3, 3, 5, 7. All right, so I know how to solve this. Trying to remember why I marked this combination. Well, let's play around with it and see. Okay, so number 5. Okay, so we're looking for the number to be 2, 2, 2, 3, 3, 5, 7. Right, so out of okay, we'll have those available digits. What's the chance they show up in that order? Okay. The way I would put it together, we'll see why I marked this. Mark that is that the first digit to be a 2. Well, there are 3 2s out of 7 options. So I would say the chance of this being a 2 is 3 out of 7. Okay. Now, suppose you pick that first number. It is a 2. Right now that you have that locked in place, one of the 2s is already expended. Now there are 2 2s remaining out of 6 remaining numbers. So I'd say the chance that the next number is a 2 is 2 out of 6. Okay. And the chance that the next number is also a 2. Well, now there's only 1 2 remaining out of 5 options, so that'd be 1 out of 5. Okay. The chance that the next one is a 3. Well, there are 2 3s to choose out of 4 numbers. Okay, these 4. Okay. The next one being a 3 would be there's only 1 3 remaining out of 3 numbers. Okay. And then next number being a 5 specifically, well, there are 2 numbers remaining, so it's 1 out of 2. Now, by the time you get to the seven, there's only one number remaining, so it has to be, right? Like if all this already happened, then by the time you get to the last number, it's just gotta be that. Okay, so this would be, let's see, three times, okay. So 3 times 2 out of 7, 6, 5, 4, 3, 2, 1. This is 7 factorial, right? Right. Anyway, let's go solve the rest of this here. The rest. So let's see, okay. Well, let's see, 3 times 2 would cancel with the 6. Yeah, this 2 cancels with this 2. So 7 by 5 by 4 by 3 and then by 1 first, right? And so that's a 1 out of 420. Yeah, and the textbook is saying that's the answer. Okay? It's 1 out of 420 that you would put those numbers in that order. All right. Wait. Why did I mark these combinations? I don't know. You might be able to make a connection. Like if you take the reciprocal, I definitely see this denominator here is 7 factorial. So you could think on that of it, right? But yeah, quick recap here. Quick recap. So here's the very first page I showed you guys. Okay? If you are looking for to draw out of the list of options in a specific order, that's permutations. You can use this in the calculator, but here's what it's doing behind the scenes, right? So the example I did with the guys was if you want to draw 4 aces in a specific order, have to choose those spades first and then diamonds, clubs, and hearts in that order. You do permutations, 52 permutations for, right? Now, if you don't care about the order, that's a combinations question. Okay, so, which is more likely to happen probabilistically. Like, I want to draw 4 aces, but I don't care about the order. You can do 52, choose 4. Okay, and then here's what it's doing behind the scenes. You can punch that in the calculator. Okay, it's more likely to happen. Right? Okay, so there's permutations and combinations.